Okay, let's get started. Good morning, everyone. How was the party yesterday? Enjoyed it? Still feeling fuzzy? We'll try to make this engaging. My name is Igal Edry. I'm a program manager in the Windows Server team. I kind of own what we internally call the hosted cloud scenario, or how you take Windows Server 8 and build clouds using it. So that's my responsibility.
Hello, my name is Ross Ortega. I'm a program manager in Windows networking, looking at Hyper-V network virtualization, and also PowerShell management of networking. And in Windows Server 2008 R2, I spent a lot of time focused on 10 gigabit Ethernet, so 10 gig offloads, 10 gig performance characterizations. And so I'll show you kind of how our thinking's progressed from R2 as we now think about Windows Server 8.
Thank you, Ross. So just to recap, I think I'm getting some feedback here. Just to recap, how many of you have been in the session yesterday that I gave with Jeff Woolsey? Show of hands. Okay, so not everyone. So I do want to make sure we set the context right, okay? Windows Server 8 is cloud optimized, and when we say cloud optimized, we really mean we enable multi-tenancy through a set of technologies like network virtualization and dynamic placement. We enable you to build high-scale clouds using Windows Server 8, and we take advantage of hardware, high availability features, SMB shares, all of that, and it's very manageable and extensible. Today's session is really about how you actually build the cloud, how you design those building blocks, those servers, those systems that will enable customers to build their private clouds or public clouds. When we say clouds in this context, we mean infrastructure as a service clouds. So you run your private cloud, and you have your customers, your tenants, bringing in workloads to your environment and onboarding them into your virtualized data center. And that's what we'll focus on today. One more thing to try to get a feel of who we have here in the audience. How many of you are engaged in building management software for enterprise customers, hostels, etc.? How many of you are in the hardware business, designing systems, designing servers? Some people. Any IT architects in the audience? Okay, so we have a nice mix, and some people who didn't raise their hands, so I'm guessing they're just interested in cloud in general. So what I'm going to ask you is to look at this deck, at this presentation, with different lenses. You each have your own different role or your own different engagement around clouds, and you all probably are working with your customers to go and are going to help them deploy clouds that are based on Windows Server 8. This session is kind of focused around the implication on hardware and how servers are going to look like in a cloud, but it has implications around how management software is going to be built. If you're an architect, IT architect, how are you going to design the system? You can look at this from many different angles. So just like put on your own lenses and let's start. So what are we going to do? We are going to start by talking about the different considerations customers are going to have when they are designing their clouds. And we're going to see that there is no single type of cloud. People will need different things. We're going to deep dive into network topologies of how a cloud data center looks like, storage topologies, and then follow with, again, if you're a hoster or if you're an enterprise IT and you're building a private cloud, the level of, or the service level that you're committed to are going to significantly impact how you architect your cloud and what exactly you need from the servers and from the management software. So we're going to take a look at that. And the goal of this session is really to help you put it all together. And we'll do that by showing you some representative configurations that we have actually built, getting ready for shipping Windows Server 8 and experimenting ourselves with the set of features that we've built. And we'll show you what we've done, and hopefully this will help you understand the big picture and how you put all of those features together. So if you're like me, and I joined the team to take on this role about a year ago. And the first thing I saw is this huge list of different acronyms, technologies that are part of the Windows Server 8 design. And if you're like me, you either start being curious about each of them and want to use them all, or you are overwhelmed and you don't know what to do. And we expect that that's what actually will happen. When people look at this, and try to decide which one is appropriate for them, they will make choices. They will make difficult choices. It's not about using everything. It's about how do I make the best of each feature, and how do I put them together and build something that makes sense and that fits my needs. That's what it's about, right? So it's important to understand that there is no one-size-fits-all. We're not going to come up with a single, hey, this is how clouds look like. If you do this, it would work. It's important to think about the different needs and then, as a result, different architectures. And what we're hoping to achieve is that we're hoping to be able to give you some best practices, some guidance, so that in turn you can help your customers design the right things. And if you're building software for the cloud, be aware of these best practices, be aware of those different trade-offs and choices, and make sure you take them into account in your work. That's really what we are hoping to do here today. So let's start. And if you're a customer and you're going to start building your cloud, you're going to start thinking about what are your requirements. What do I need in terms of high availability? How much do I need to scale? How reliable is the system supposed to be? Like, do I need everything to be completely reliable? What kind of performance do I need? Security considerations, cost considerations. All of these are requirements that you're going to have to think through, right? And it turns out that when we think about all of this, at the end of the day, it really translates into a set of 4 choices that we will talk about today. 4 different key considerations, key things that customers will think about when they're designing their cloud. They will think about workloads. What is it that I'm going to run in my cloud? Who are my tenants? What exactly do they need from me? How are the tenants going to look like? Then they will think about their network topology. They probably have a data center already, or if they're starting from scratch, they have some opinions, biases, reasons why they believe the network should look this way and not that way. So they will think about network topologies. Same for storage. Some people use this type of storage. Some will have bias for another one. Some of these biases would actually be driven by real requirements, and some are kind of, that's how I used to do things. And actually, when we get to storage, we'll see that Windows Server 8 changes a lot of the, or has the potential to change a lot of the perceptions around how the storage should look like. And then they will think about the service levels. What am I promising my customer? And how does that impact the way I'm architecting my cloud? So what we'll do in this session is we'll go through each of these 4 different choices or consideration areas. We'll understand the trade-offs. And once we do, we'll end with this set of representative configurations that actually put them all together into things that make sense. Okay? So let's start with workloads. This is really where it all starts. If you are building a cloud, the first thing you ask yourself is, why am I doing that? Who is my customer? What am I going to host in my cloud? If we're talking about infrastructure as a service, and the first question you ask yourself is, am I going to host cloud-aware applications, or am I going to host legacy application, legacy servers, just take VMs from my customers and run them as is, and I can't assume anything about the VM, what's actually running in it? Then that's really a key question. And usually, infrastructure as a service translates to legacy stateful apps. It's not apps that were designed, for example, to run on Azure and have cloud awareness kind of built into them. It's more of the legacy thing. Okay? So you probably can't make too many assumptions about the resiliency of these workloads. Do they know how to fail over, etc. However, it does turn out that when you look at large hosters, and that's usually more the case with external hosters compared to private clouds, that they do make some assumption. They basically say, you bring me your VM and I'll run it, and if it's not aware of failures, then it's kind of your problem. You'll have to solve it. So there is a kind of a balance here between how much do I assume about the app and how much do I want to guarantee that I'll take care of making it cloud aware. So question number 1 to ask yourself, are you going to host VMs or services that are aware of the fact that they're running in the cloud? Second thing you want to ask yourself, or the customers would ask themselves, is, do I trust all of my workloads? Why is that important? if you are running a private cloud environment inside an enterprise, you know who your customers are, you know that they're all kind of good citizens, you can make certain assumption about them not trying to attack each other, not trying to take down other services, etc. And then you can make some design decisions based on that. If you are a hoster, a public hoster, and you are building a cloud to enable your customers to come on board, you really cannot make this assumption anymore. You have to take care of guarantees like quality of service on the network, maximum guarantees, so that if some workload starts misbehaving, you can actually stop it from doing that and not interfere with other workloads. If you are taking advantage of hardware features such as single route I/O virtualization, SRIV, that basically allows a VM to talk directly to the hardware, you want to be careful because you're kind of starting to open up the isolation door between those different VMs, and that's not good, right? So are my workloads trusted? And as a result, probably what you'll want to think about is quality of service and considerations around SRIOV. Do you want to use that or not? Next question about a workload is, what are they doing? Are these workloads mostly compute-bound, running, like needing CPU calculations? Or do they do heavy I/O? Do they need to be, for example, close to the storage? Or do they don't care because most of the thing they do is spending CPU cycles? And that, again, will impact the way you architect your cloud. And the last thing you want to think about is the workload size. Do you want to run many different, like, are you running small apps? Or are you designing your data center, your cloud, to run very heavy applications? Like, if you're designing for some workload that needs 32 virtual processors, and you're probably not going to run this on a 2-socket machine, right? You need stronger physical server. If you are architecting for the mass market of VMs running web servers, each of them, and just each one needs 1-2 virtual processors, then you probably want to go with the thing that's the best ROI in market today, which is a 2-socket server, and that's capable enough. And that also helps you with the consolidation ratio, which is you don't want to use like a very big server with large number of sockets and then end up with hundreds of VMs running on each server, which kind of creates a problem of too many eggs in the same basket. And although it would work, most people would not feel comfortable doing that. When we talk to customers and hosters, usually what you see is that they feel comfortable with a consolidation ratio of 20, 30, 40. That's about it, right? You don't really want to run 400 VMs on the same server. So the workload size really has an impact here, because what you may end up wanting to do is designing some mixed environment where you have some nodes with 2-socket servers for the common workloads and some nodes that are strong for those especially demanding VMs, and have your management software manage that, like where do I place each of those workloads? Which goes to the point that you may actually want to combine these things together. You may want to build a data center or a cloud that actually supports all of these in different places. So this is one area. And I think that this is really the one that customers will start with. They will start with thinking, what am I going to run? And therefore, what do I need to do to make sure that I can support these kind of workloads? The next area is the networking considerations, and I'll let Ross talk about that.
Great, thank you, Yigal. So I'm going to go from a pure siloed networking focus. So some other issues, Yigal will come back later on. So I just want to set the context of how we start thinking about this. So the first thing is really isolation in a multi-tenant environment. Now, yesterday I talked about Hyper-V network virtualization. That was from kind of the guest perspective. This is separate from that. And just let me caveat that the Hyper-V network virtualization talk will be in this room right after this session. So we'll go into a lot more technical details about how to build scalable multi-tenant clouds. Here's more from the hoster perspective. But in that talk yesterday, I said, VLANs were not really designed for a dynamic multi-tenant environment. But they do have a use for more static type topologies, and that's one thing to think about when we're talking about isolation here. And the consideration to be thinking about, do you want the parent traffic and the guest traffic on the same wire? So if you go to our website today in Server 2008 R2, we recommended 4, 5, or 6 NICs to do pure physical isolation. And we understand that's a bit expensive and complex to do that, but that gave you a lot of really good performance and isolation, so that was one way to solve the problem. But really when you start thinking about this, and the reason why this is important, because it goes down, the main pivot that we'll look at is how many NICs should be in the server itself, you know, when you start looking at that. And what we're seeing in the industry today, so the sweet spots emerging right now seem to be 4x1 gig NIC. You can definitely buy a Nehalem class machine with 4x1. That gives you some flexibility in how you partition out your VLANs or how you start mapping out the traffic. The other sweet spot we see emerging is probably 2x10 gig NIC. And so that again kind of influences, and so there's something called LOM, LAN on motherboard. So these are built into the motherboard and power requirements are coming down. So that will influence it, but really the basic line is isolation. So, and again, kind of our focus here is there are different types of clouds. So there is no one size fits all cloud. And so how I think about this, or how you should be thinking about this, if I'm building a private cloud, let's say I'm doing this inside Microsoft, so I know everybody's a Microsoft virtual machine. I basically know the owners of those machines. That's one trust model. And I know that in my cloud, within the private cloud, I have high-speed network access to that. So again, that influences what kind of NICs I want to use, and think about that. If I'm doing a public cloud or building a public cloud on Windows Server 8, then I need to think about kind of the traffic patterns that are coming in. And that will influence me as well. So you'll hear us in networking talk about north-south traffic and east-west traffic. And so if you're not familiar with this, north-south means coming in and out of the data center. So in and out this way. So an example would be, let's say I have a web server and I have a bunch of clients out in the world somewhere hitting my web server. That would be the north-south traffic. If I have server-to-server communication, that's east-west traffic. So that kind of traffic that's going in the data center. And internally, we've been measuring very carefully data patterns or packet patterns in the Microsoft data centers. And our observations are basically 70% of the traffic in kind of the private clouds is really kind of east-west traffic. So those are different types of optimizations you need to think about when you start looking at that, whereas 30% is kind of in and out of the data center. And that kind of makes sense when you think about network traffic, that you'll make a request to a server, and that's kind of a very small packet, basically a very tiny request. Then a lot of stuff happens as you start making SQL requests, going in and doing these things. A lot of computation that's packaged up, and then a tiny request coming back out. And that's kind of basically what we're seeing in that. So basically, what we come back to the isolation, we need to think about how we partition that out. The other thing is now greenfield versus existing infrastructure. And a lot of these costs, when we start thinking about how to build that, are not necessarily tied to technology, but more tied to operations and operational efficiency. So greenfield gives me a lot of flexibility. We've introduced a lot of new features in Windows Server 8 and a lot of technologies, and so that's a really good opportunity to try something new here, you know, a much better approach. But if you're doing incremental deployments, so let's say I'm bringing in a new rack on Windows Server 8, then I really got to think about kind of what existing technologies are in there, more from a management operational perspective. Like, do I have 1 gig? Do I have 10 gig? How do I manage that? What are the capabilities of not only the servers, but the switches, and then mixing Windows Server 8 with Windows Server 2008 R2, and the different capabilities and features, and how do I really think about partitioning in the data center? And then kind of coming back to traffic management, how do I manage the traffic? How do I worry about things like QoS? So those are just kind of set the backdrop, but let me dive a lot deeper into how we're really going about this. So in terms of like technology, greenfield, incremental, you know, do I care about performance, and how much do I care about performance, and what am I willing to pay for that performance? So one thing to think about is InfiniBand versus 10 gig E versus 1 gig E. So let me compare and contrast 10 gig versus InfiniBand, because that's probably the first thing. 10 gig, we get really good performance. I mentioned we spent a lot of time optimizing 10 gig in the last release. So that's really good. We've introduced RDMA, so you should expect RDMA on your 10 gig NICs coming out. SMB takes advantage of RDMA, so out of the box, when you talk to a Windows file server, we'll go RDMA. And if you're not familiar with RDMA, it's a bypass technology. It's like direct memory access, but now it's remote. So the CPU doesn't need to do that. The advantage of all this is that we can get high throughput, very low latency communications going on. So for storage, that's a really good thing. We also, on 10 gig, and let me just take a step back a bit and talk about 10 gig. The new NIC technologies, you tend to see them coming out on the 10 gig NICs. They're not appearing on the 1 gig NICs. And that's really just economics right now. The price of the 1 gig NICs are essentially free for all practical purposes, right? So there's no money to be made there. So all the innovation that we're seeing occurring in the ecosystem is occurring on 10 gig NICs. And that's an important consideration for us, because I'll talk about a lot of the offloads. Those offloads are popping up on the new higher-end NICs in the server space, not on the 1 gig NICs. So things like DCB. So DCB is part of the alphabet soup that we talk about of technologies, data center bridging. Basically, it lets you do quality of service in the NIC, so I can do classes of service that way. So if I want to build out a cloud and think about gold, silver, bronze service coming out of the guests, I can now use DCB hardware to help enforce that quality of service. So the thing is, 10 gig switch ports are still a bit pricey relative to 1 gig. I mean, the slopes are pretty interesting. The price continues to come down. The price point now is probably in the $400 per port range as 10 gig adoption really kicks in now. And so I think we're kind of at that thrust point. So we should expect 10 gig everywhere. And when thinking of planning out the data center, these data centers need to live for a long time. Depending on the workloads that you're thinking about, 10 gig is a good solution for that. Now, if you want screaming fast performance, probably InfiniBand is your answer. So you see InfiniBand adopted by the financial services, where the transactions per second and low latency is absolutely critical. And so you see things like DDR and QDR, so very, very fast. So a little less expensive than 10 gigabit Ethernet. You get RDMA, again, for that low latency, high throughput types of things. But the decision point probably is not necessarily on the cost of the technology, but on the cost of the management. So there are a lot of people that understand how to manage gigabit Ethernet and just Ethernet type networks. You need kind of a different skill set for InfiniBand. So that would be a major consideration that's not necessarily technology focused, but more operations, personnel training, supporting different types of technologies. And we're aware of very few pure IB deployments, so you still need a mix of the Ethernet knowledge as well. And then gigabit Ethernet, it's everywhere, right? It's just everywhere, and is that good enough? So if we think about what the traffic, if all my traffic is north-south, so one interesting observation is that WAN traffic, the price of WAN traffic is not really moving. It's stuck, right? So, and there's no technology we're aware of on the short-term horizon that's going to make that go down. Now, one of the manifestations of the cloud, it drives a lot of WAN traffic, right? That's kind of the promise of it. But, who can afford that? And so what's interesting about this, who has gigabit Ethernet at home? Not very many people, right? So how much bandwidth do you need going out of your data center? Now, if most of your traffic is north-south, then 1 gigabit is probably good enough for you. And so this is kind of an isolation. Now it gets even more fun when we start really building systems, and we'll show some examples of this. But it's not like you have to commit to one of these technologies, right? This is kind of on a per NIC basis. And a lot of talk will focus on constraints, but you can mix and match these. So let's say most of my traffic is north-south, but I want really fast live migrations and storage backup. So then I can put 1 gig NIC on the VM switch, and I put a 10 gig NIC on the parent side. So we can really start mixing and matching all these technologies. So let me show you a couple layouts of what that could look like. So the main pivot here will be how many NICs are in the system. Again, 4x1, 2x10, some mixture of those, and how I lay that out. So that's really how we think about this when we start doing configurations. So here's an example. This is basically what we've recommended before, doing physical isolation here. So here, just let me explain the picture. I have live migration traffic, and I'll put that on one NIC. I'll have cluster storage, I'll put that on another NIC. Management traffic will be on one NIC, and the Hyper-V extensible switch will be on a different switch. So all my guest traffic is now isolated. We've introduced port ACLs in Windows Server 8, so I can isolate the guest VMs from each other just using port ACLs if I want to. So here is this, and here I'm not putting any speeds on this. So here, out of the box, you can do your 4x1. If you have really high performance constraints, you might want to use a 4x10, but we're not aware of any of those types of deployments now. And let me just have another comment on 10 gig. I spent a lot of time in R2 doing 10 gig performance analysis. And it turns out it's really hard to fill up the 10 gig pipe. And Windows is designed, and we've optimized for 10 gig. And so we have no problem pushing 10 gig. And in a heartbeat, I can show 10 gig, and we'll fill up those pipes using micro benchmarks left and right. We use NTTCP internally. The industry tends to use Chariot. But to use meaningful traffic, and recall that when we talk about 10 gigabit Ethernet, this is kind of a unidirectional thing. So that means 10 gig going out and 10 gig coming in when we say 10 gigabit Ethernet. That's 20 gigabits per second of bandwidth. Now, how do you usefully use that? It actually is a real challenge. Now, it gets more interesting as we look at convergence. If I'm using storage traffic on that, then the requirements go up. And then one other thing that we've seen in terms of adoption, that people were adopting 10 gig because they didn't want to manage multiple NICs. But that becomes a lot easier now in Windows Server 8 because we've introduced NIC teaming in box. So our observation was, particularly on the native side, that people needed more than 1 gig. They probably needed about 3 gig, not necessarily 10 gig. And so now, the options that we give you become more interesting. So we have a lot of flexibility. As Yugal mentioned, it's not that you use all the technologies, but you have a lot of flexibility when you design your SKUs for the cloud. So here's another example of 10 gigabit Ethernet. Here, pretty much whenever I'm mixing my storage traffic with anything else, you're probably going to want 10 gigabit. You really will want that kind of performance. So if I want to mix anything, and here you see them mixing, and then on the right side, whether that's a 10 gig NIC in a 2x10 configuration or a 1 gig, again, if I have primarily north and south, I would use 1 gig. Now, one thing here in this configuration, here, but coming back to isolation, this is an example where we would use subnet isolation. So live migration and the management, for example, would be on different subnets. Now, one interesting thing that we've introduced with NIC teaming is that I can put a team of 1. And with the team of 1, what I can do is what we call a TNIC. So I pop that up, different TNICs. And those TNICs are isolated by VLANs. So if I wanted to do VLAN isolation, so let's say I have a live migration VLAN and a management VLAN and a storage VLAN, I could then put NIC teaming in here with a team of 1 on that NIC. And then instead of using just pure subnet isolation, I could use VLANs just like I used to use before. Now, in the past, we recommended different NICs primarily for predictability. So let me show you another example where we kind of really relax that requirement. Here's an example where I have one 10 gig NIC, and I'm going to route all the traffic through the Hyper-V switch. Now, again, we recommended different NICs, not only for isolation, security isolation, but really for performance isolation. And so we've introduced QoS now in Windows Server 8. So I can do QoS on all these switch ports. So I can say, and it's a very flexible QoS mechanism. And we'll have a talk later today that goes really into details of this. But let me just give you an example. Let's say I allocate 3 gigabit of traffic for live migration and 4 gigabit for storage. And then I have 3 gigabit for the rest of the stuff. So I have allocate all my 10 gigabit. So let's say I'm not doing any live migration now. That 3 gigabit is not it's reserved, but it's available to everybody else if I'm not using it. So let's say, let me do another example. Let's say there's no traffic going on in my server, and I do a live migration. Even though I reserve 3 gigabit, if nothing else is going on, I'll get the full 10 gig for my live migration. So I get all that bandwidth available to me. Now let's say I want a management traffic, and I reserve 1 gigabit for management traffic. As soon as I start doing management things, the 10 gig from the live migration will drop down to 9 gig, and I'll immediately give the 1 gig to the management traffic. So now I have this flexible partitioning of my bandwidth, but I can now make it predictable. So there's no starvation that's going on. So now I have this flexible thing of carving up my bandwidth. So we're always effectively utilizing the pipe. So when these services need to use that bandwidth, we can give it to them. So this is a new type of architecture that we've introduced. If you're familiar with Hyper-V Manager, in the GUI we don't show this. What we do is we use PowerShell for this configuration. This is kind of a more advanced configuration. We have a talk tomorrow about configuring everything in the networking subsystem with PowerShell. But this is kind of a new way of thinking about this. And so this is kind of a fully converged system with 1 NIC. Now, if you had 2 10 gig NICs, we would team them. You might want teaming for reliability. and it would put them in a switch independent mode, and it would look just like this. I just have another 10 gig NIC next to it. I would team them, bind that to the Hyper-V extensible switch, and then run all the traffic again through that. And then we could use ACLs as well. So by using either VLANs on the switch ports or ACLs, I can now isolate my parent traffic from my guest traffic. So we can give you isolation, and we can give you QoS in this type of configuration. Now, one thing we really care about in Windows are offloads. So offloads basically move some of the functionality from the operating system down into the NIC hardware. And there's some benefits from this. One thing is we drop CPU utilization. So that leaves more CPU to do more useful work. But another thing is that by dropping the CPU, we drop power consumption. By bypassing the stack or moving some of the functionality into the NIC, we also drop the latency. So we lower the latency. And then we also increase scalability. So we focus a lot on the offloads available, and most of these offloads will be available in the 10 gig NICs as Windows Server 8 begins to hit the market. So I mentioned DCB, that's QoS in the hardware. Receive segment coalescing, we have a talk later today to talk about that as an optimization. I'll have a slide on receive side scaling. Receive side scaling, probably the most important offload that we have for native performance, and its complement down towards the bottom is virtual machine queue. How do we scale and effectively use all the processors? Mentioned RDMA. SRLV is interesting. SRLV basically exposes the NIC to the guest. So that's something new that we have, and it supports live migration. So a great example of that is if I have a SQL server today, let's say I have a physical SQL server, I want the benefits of virtualization, live migration, kind of backup. There's so many benefits of just managing something in a virtualized environment, but I want the performance that SQL demands. So SRLV will expose the NIC directly to the SQL VM, so I can get very good high performance, low latency. I can take advantage of all the offloads. From the NIC's perspective, from the VM's perspective, it looks like it's talking right to the NIC and getting near native performance. So SQL is a great example where I'd want that. And as Yigal mentioned, you really need to think about the security model with SRLV. And SRLV is bypassing the virtual machine stack, our stack, the Hyper-V stack. And so the ACLs and the QoS are something that you wouldn't get in that scenario. So it's a different kind of trust model. So in a private cloud, you want to use SRLV for those kind of high performance workloads like SQL. In the hosted cloud, it's a kind of a different security model. You don't know the owners of those VMs. So you may not want to use in that case, or you need to be aware of the different types of things. So we have different kind of anti-spoofing security features in the stack that you don't get on the SRLV path. And then we've introduced IPsec task offload to the guest in this release as well. So if I'm having IPsec traffic, the guest now can take advantage of that. So all the encryption operations are happening in the NIC. So the CPU utilization drop is tremendous using IPsec task offload. So now let's see how we use offloads for better scale. So here's kind of a standard configuration. We're kind of looking at this now. With QoS, we get predictability, so I can go down to 2 NICs. Now, receive side scaling, in R2, we publish results. We get basically 3x performance. So if you're not familiar with receive side scaling, basically in Windows, all the received network traffic is going to one CPU. Let's call it CPU 0. Let's say I have a 24-core machine or a 32-core machine. As soon as I hit CPU 0 at 100%, I'm done. I can't do any more useful work. I'm working as fast as I can, but that CPU that's receiving the traffic is receiving as fast as I can. So with receive side scaling, what we do is we look at the packets coming in. So we look at the IP source and destination. We look at the TCP source and destination. Based on that 4-tuple, we do a hash, and then we'll spread it out. So we'll spread out the traffic across the CPUs. So that's on the native side. And we have a complement on the Hyper-V switch side called VMQ. In that case, what we're going to do is look at the MAC addresses coming in for the packets and then route that traffic. So this is kind of the picture I've been using, but if you kind of look behind it, what's really going on is that we have receive side scaling spraying the traffic in a predictable way. So we preserve in-order packets. So that's very important to us because if you didn't do that, you'd lose a lot of performance on retransmits. So we have receive side scaling spraying out the traffic on the native side. We have VMQ for the Hyper-V switch side also spreading out that traffic. So these are both very important scalability offloads. You definitely need to use them, particularly when you're looking at 10 gig performance. And one thing I learned doing performance testing is everything's a caveat. So if you look at anybody's performance reports, you got to read every single footnote. It's like a financial report. You know, nothing's interesting in the top level financial report. Everything's in the footnotes because that's all the details. How do you replicate what would happen here? So here's my first footnote. RSS and VMQ cannot be enabled on the same NIC. And we basically don't support RSS on the Hyper-V switch side, except through the SROV path, which is another little caveat. But this is kind of the architecture we're looking at. So let's talk about footnotes. So when we talk about what's compatible and what's not, this is on a per NIC basis. So that will be my first footnote here towards the bottom, the 1 star. This is very important to remember. This is a per NIC basis. So if I go back to kind of the 4 NIC situation, then I don't have to worry so much about all these offloads, but I'm making some choices. So the fundamental choice is raw performance versus flexibility and scalability. So the best way to get raw performance is to get Windows out of the way and just go straight to the hardware and make things screaming hot. But we work very hard to add value and do interesting things to help customers with the Windows stack, things around security, things around QoS. And so some of these offloads will bypass that. So RDMA is a stack bypass technology. So it bypasses the Windows TCP stack where we have security and other features in there. So you give that up, and so there's some trade-offs with RDMA. SROV bypasses the virtual switch that we have. So port ACLs, port mirroring, PVE, and all the stuff that we've introduced in the Hyper-V switch is bypassed. So, and when we think about this, so you're bypassing the Hyper-V extensible switch. Also, these bypass technologies will bypass Hyper-V network virtualization, and that's the next talk. That's how we do scalable, secure multi-tenancy. So that's a trade-off that you really need to be thinking about, again, on a per NIC basis. So like Hyper-V network virtualization, that only applies to the guest traffic, right? So I can get these other offloads on the parent side. I don't have to worry about that. So it really depends how many NICs I have in my system, what features I want to look at. So NIC teaming, RSS, VMQ, IPsec task offloader as well. So that's kind of what you need to be thinking about. And again, probably the most important caveat, this is on a per NIC basis. So this is really important if I'm going to a 1 NIC configuration. So if I go to 1 NIC configuration, then I have to really worry about what works with what in what scenario here. If I have multiple NICs, we kind of ease that up a bit, so then I can focus on the native and the switch. So we tend to gravitate more towards a NIC for the parent traffic and a NIC for the guest traffic. So again, that's just kind of a quick perspective from a networking siloed view, and now we'll bring it back up and look at kind of storage and resiliency and other considerations.
Thank you, Ross. So we've covered networking, and as you've seen, there are many trade-offs there and many different choices to be made. Similar thing happens on storage. So before we start talking about storage, I just want to make sure we're using the host bus adapter HBA terminology for some people use it for different purposes. So I wanted to make sure that we are clear about what we mean when we say HBA. And really, you can think of NICs or network interface cards as the thing that connects you to the Ethernet and through a TCP/IP stack. HBAs, when we talk about them in this context, is really, usually it's this special connection to storage. That's how I think about them. They bypass the network stack. They could be a fiber channel adapter. They could be an iSCSI with offloaded TCP traffic, still called an HBA, and it's really used just to connect to iSCSI storage devices. It could be a SAS card. Different people have different interpretations of this term. The way I think of them is really, it's about the wire. If you want to connect to an Ethernet switch, use a NIC. If you want to connect to something that has this special infrastructure, special connectivity, we call it an HBA. And people tend to use, obviously, both. Some people, when we go to a converged fabric, try to move their storage to be routed over the Ethernet, over standard NICs. Some still have a lot of investment in storage that has its own dedicated connectivity. Both are valid. Just want to make sure that we understand that HBA usually means dedicated storage connection, doesn't go through the TCP/IP stack. So let's talk about the bigger picture of storage architectures. And there are really two possible approaches. There are two extremes to how I approach the question of storage in my cloud. One is I have my storage and my compute mixed together. Within each server, Hyper-V server, I have either directly attached storage, like some SATA drive inside the box, or I'm connecting that to some SAS drives, but they are still tied to this specific node, to this specific server. In this approach, you end up with the data center, with the cloud, where the compute and storage are not really separated. If you walk around the data center room, you wouldn't see a rack for storage and a rack for compute. You would see a rack that has both in it. That's one approach. You usually, this kind of approach drives the cost down. You don't need to rely on expensive storage devices. You may want to do it when you have when it's important for the VMs to be close to the storage. Both are valid considerations. So that's approach number one. Approach number two is really to separate these two out. You want to scale on two different axes. You want to be able to scale your compute capacity, and you want to be able to scale your storage capacity, and you want these two to be two different decisions. Okay? There are actually two ways to do that in Windows Server 8. One is the old traditional way, which is to rely on SANs and have the Hyper-V servers basically connect to SAN storage shared, and that would be like separating Hyper-V and storage. And in Windows Server 8, we're introducing the support for file servers, where you can still think of the file servers as a separate storage device, and the file servers are the thing that actually connects back to the actual disk, to the actual storage. Right? And actually, if you think about it, the file servers could connect to local storage themselves through technology, through SAS and leveraging technologies like Windows Server or the new feature called storage spaces. Or they can use your existing SANs in the backend, but expose it as SMB shells to the Hyper-V nodes. I'm just curious, I don't know, how many people here are actually involved in running a data center? Show of hands. How many of you are today with this is your left or your right? The compute and storage mixed together. How many of you are building the data center like that? How many of you are? One. How many are separated? All of the rest? Okay, that's what I thought. I think in today's world, this is really the most common thing. There are some valid reasons for that. I was actually reading one of our own Microsoft private cloud reference architecture guidance, and it was explaining that you have to do the right thing, like the separate SANs, to enable live migrations and complicated scenarios. Now, if you've noticed, in Windows Server 8, you can live migrate across anything. That's no longer a constraint. So it leaves us with the other consideration that maybe you feel more comfortable being able to scale each of them separately. Maybe you really like in this trade-off between driving the cost down and using highly available and resilient storage, or maybe you have your own investments already in this kind of storage. Maybe you'll stay with the right approach. But we think we've opened the door to allow you to actually freely move between these two approaches if that's what works for you. Okay? But both are valid. Specifically, if you want to learn more about these and how you design systems for continuous availability with different storage approaches, then there is session 446 and actually also 444 that are happening later today. And there is session 451, which is specifically around Hyper-V and how you design continuously available systems for Hyper-V. That's happening tomorrow morning. So if you want to follow up on these, go to these sessions, understand that a little bit better. Last, before we dive into the actual representative configuration and how it all fits together, let's talk about service levels. So if you're a hoster, you start thinking about what performance guarantees do I give to my customers. And at the first level, it's about what do I promise, like what kind of bandwidth do I promise workloads, how much internet connectivity do I give them, and how important is it for me to isolate them from each other, meaning do I want to make sure that customer A gets at least 1 gig connectivity, and do I want to make sure, do I also want to protect myself against some workloads that are trying to abuse the system. That usually has some implication on the management software, on how you manage your cloud, less implication on the hardware and how the servers actually look like. It's mostly a software feature. You may want to take advantage of DCB offloading to do QoS on the tenant side of traffic, but that's kind of an extreme case. The more important decision you made about your service level agreements or the service that you're going to offer to your customer is about your resiliency promises. And that's where we come to, again, two different approaches. There is always these two extremes that you have to either choose between them or find yourself somewhere in the middle. So let's talk about these two extreme approaches to resiliency, which are really driven by what you want to offer your customers, your workloads. So one approach is, I'm assuming that the VMs are designed to fail. I don't have to take care of that. What I really am interested in is driving the cost of my data center, my cloud, down as much as possible. I'm going to try to use the lower-end standard industry server as much as I can, and it's because I'm very, very cost-sensitive, and I can make assumptions about my workloads, right? So I may do clustering for management, but not necessarily for failover. I'm trusting my VMs to know how to fail, or I'm not even offering an SLA around no downtime. If one of my servers fails, that's good, because my SLA says that this could happen. And it turns out that this is really typical for hosters, large-scale hosters. That's what they usually do. When we talk to hosters, you see this a lot of the time. If they go to the other extreme, they start positioning this as the very high-end offering they have. But that's one thing. If you look at our own public cloud, at Azure, each server is really not highly available by itself. The resiliency is built into the application. You write to the application platform. Therefore, we run 2 copies of everything or multiple copies of everything. If one fails, that's fine. It's an applicative thing. It's not built at the data center level. Okay? The other approach is, let's make everything as highly available as possible. We cannot have VMs failing. We cannot have workloads failing. The server infrastructure have to take care of that by introducing full resiliency. You start seeing double network infrastructure, double the switches, 2 power connections to every server. You see them coming in clusters. Failover clustering will take care of the case where if one server fails, the VMs automatically start running on another cluster member. It's really designed for failure. It's designed to handle failures, not designed to fail, but designed to handle the failures in a good way so that the workload do not notice it at all. Okay? That's the other extreme. You kind of see this in private clouds. The reason is they're usually designed to run some legacy applications as well that are not able to deal with the failures themselves, so the data center takes care of that. Your cloud is built for resiliency. When hosters do that, they charge more for this kind of service. You get better SLA, okay? We actually believe that moving forward, as much as we see customers moving their existing workloads to the cloud and moving to the hybrid cloud, they will expect these kind of SLAs for them, because they will move not just workloads that were designed for running in a cloud and designed in a different way. They will want to move their existing systems to a cloud provider, and therefore they will expect from this cloud provider the same level of SLA that they expected from their own private cloud. So we think this is going to happen more. Surprise, surprise, this costs more money. And we've actually made a lot of investment in Windows Server 8 to drive this cost down. So we are making it easier for you with features like NIC teaming built out of the box, with support for low storage. With many of the different features we've had, we're driving the cost of building such a data center down. So easier to do. So we've talked about these different, 4 different pivots of considerations: workloads, networking, storage, service levels. Kind of tie them to those requirements around high availability, cost, etc. Let's start to actually boil it down to practice. What does it actually mean when you want to build servers that will power your cloud? How do they look like? So before we represent them, just remember, we have different options. So I'm not going to show you one. We're actually going to go through a flow of different options, from the one extreme, which is what you can do today without 2, with looks very, very similar to our current reference architecture of how you build the cloud today. And we'll go through a series of changes to this configuration to something that we could consider as a greenfield, or some new configurations that we I believe are going to make more sense and be more cost-effective for you to do when you're building a cloud using Windows Server 8. So we'll go through this flow. An important note about that is that we're actually been validating those at Microsoft, the Engineering Excellence Center. We've been building those different configs, experimenting ourselves. If you know anything about big corporate organizations, and Microsoft is certainly one, we have features coming in from different teams in different reporting orgs, in different philosophies even sometimes, and putting it all together and making sure that it works is really critical for us to be able to tell you, hey, you can do that. That actually works. So we've been doing these kind of configurations, and you can expect to see guidance coming out between now and beta. Still not clear exactly when we'll be able to ship that, around how exactly to do these configs. And if you've been to the sessions until now, you also know that we are completely PowerShell enabled. So you can expect those guidance to also be accompanied by PowerShell script that shows you how to automate this kind of configuration deployments. And like the extreme is really a single script that you run. You take X amount of servers, you run the script on these servers, and you end up with a fully configured cloud environment. It's all PowerShell enabled, so it's easy to do. So you can expect this to come out, and let's start diving down into the details of how exactly they look like. So we'll start with a very basic one. You have a traditional configuration that exists today. In this example, you have an HBA connected to a SAN, fiber channel storage. You have physically isolated networks for live migration, cluster, and management. You have your VMs running on top of the switch, all using 1 gigabit Ethernet, probably something that's very common today and that people are used to do. That's the base guidelines and like the base starting point if you're using Windows Server 2008 R2, right? So let's start seeing what we can change, how we can start taking advantage of the Windows Server features in a way that makes sense. And the first thing is, let's think about demanding workload. We're able to scale better in Windows Server 8. We have hardware acceleration features that enables you to run workload that was difficult to run before. And the first thing you want to do if you have such demanding workloads is to look at the right side, on the tenant side, on the VMs, and maybe move to 10 gigabit Ethernet, leverage the VMQ support that enables VMs to scale better, and maybe even leverage single route virtualization if VM2, for example, happens to be a SQL server or something. Makes total sense. You can do that. You couldn't do that before. The rest, for now, stays the same. You end up with a similar architecture to what you have today, but you can run bigger workloads on that cloud. That's good. So step number one. You look at the other side, and that's actually something that we see when we talk to customers and ask them, when are you starting to use 10 gigabit Ethernet? Where is your network bandwidth bottleneck? It's around storage. And what we see them doing is we see them moving to 10 gigabit Ethernet for storage. It's still kind of physically isolated. You still have your 10 gig only used for the storage access. You move to 10 gig, you move to iSCSI, obviously, and you have this better bandwidth for the storage. All great, fast access. It's also Ethernet now, so you don't see these different technologies for wiring to the storage that you see where you have fiber channel storage fabric or infrastructure. So you move to 10 gig Ethernet, and many of them do that. That's exactly, if we, in the cloud environment, in talking to cloud providers, both public and private, and we ask them, where is your 10 gig Ethernet? It's on the storage side. Okay, so that's what. Now, once you've done that, why not take advantage of that and really use these 10 gigabit Ethernet for converging your hosted traffic? So we have 10 gigabit Ethernet. We probably have some spare bandwidth there. It's very difficult to actually leverage the entire 10 gigabit Ethernet for storage access. Route your cloud, your cluster, and management and live migration also to run on the same 10 gig Ethernet NIC. Once you do that, you don't want to give up on the performance isolation you had before. And that's where features like DCB come to play with QoS. You can use DCB, which is the hardware-level QoS, together with the QoS features of Windows Server 8 to classify live migration traffic, management traffic, storage traffic in a different way, and then guarantee different bandwidth for each of these traffic flows. So it's just like you had different NICs, which guaranteed like the NIC bandwidth for each of these traffic flows, but now it's all on 10 gig Ethernet, converged, but still with the right performance guarantees. So moving this left side of this hostel traffic, we call it, to be on a 10 gigabit Ethernet with DCB is really something that we believe people should do when they move to Windows Server 8. If you have already converged, then why not use file servers? Why continue using, you can still continue using your existing storage, but put a file server in front of it, and you actually get the benefit of mobility that is much better supported in Windows Server 8, that everything can move around. When you look at if you've seen the demo of the scenario where we can actually live migrate something from server A to server B with just a wire, just network wiring between us, that relies on SMB connectivity. And if you're, and in addition, file server is really more flexible, more easy to manage. You are used to doing that. So use file servers for your storage. And if you're using file servers, you can now take advantage of the high performance we have there with RDMA support. So we get to a point where if you put a file server in front of your storage, your file server can continue using your SANs in the backend, but most of your infrastructure fabric is 10 gigabit Ethernet. Any special fabric you may have to connect to the storage is just between the file server and the backend storage. The storage can actually be JBODs, just a bunch of disks with storage spaces managing those. So again, you drive the cost of the storage significantly down. And from a data center perspective, you really see a very simple fabric. You see 10 gigabit Ethernet, routing like being your backbone for connectivity between the different servers inside your clouds. We still have this separate thing of the tenant traffic, which could be like 1 gig or 10 gig, depending on what you need, right? But that's really it. So you move to file servers. Now you need high availability and you want performance. So this is an example of where you can actually do both. You can make your hostel traffic, your backend, highly available with two 10 gigabit Ethernet NICs. Use the NIC teaming features to team them together. There are two caveats here. Like Ross mentions, there are always trade-offs. If you do NIC teaming, RDMA is not supported on the NIC team, so you have to choose between the two or keep them separated. And the same with the SRV. I actually show two different examples here, one when we chose in favor of NIC teaming and one when we chose in favor of hardware acceleration. So on the hostel side, the live migration cluster management, we do NIC teaming. We don't use RDMA to access the file storage, so we don't try to accelerate that using hardware. And on the right side, we do need SRV, so we cannot do teaming, and we didn't do high availability there. But you can make these different trade-offs in both sides. The last thing I want to show is the samples and the documentation that we said we'll come up with. So you can expect coming soon documentation around how to build some specific configurations, and this is one of them. In this configuration, we've actually chosen to do teaming on both sides. We've assumed 1 gigabit Ethernet is enough for tenant traffic, so not necessarily designed for demanding workloads, but more designed for the typical workload that a VM with maybe a web server or a few proc VM, few virtual procs VM. We've taken advantage of DCB and QoS to converge all of the traffic of the hostel side. And that's connected to a Windows file server in the backend that provides the storage, again, taking advantage of the same features with NIC teaming, highly available web server, file server. And that, in turn, actually connect to your storage, your SAN that you had before, and probably coming soon after that guidance will come guidance on how to make the file server use Spaces instead of Sun for storage, which will again drive the cost a little bit more down. So this sample configuration, there will be clear guidance on how to configure that step by step, how to automate that with script step by step. And we hope that by doing that, we will help you understand the best practices and how to take advantage of the right features and how to mix the right features together and not try things that probably wouldn't work together. And in turn, you can help your customers realize the benefit of Windows Server 8 as a cloud-optimized operating system. Really, the important point here is that if you optimize what you do, your servers, your system, your management software, based on these best practices and guidance, you will help your customers build better clouds based on Windows Server 8, and we will all benefit. That's it for today. Related sessions. So there are some sessions here that happened already. You can take a look at the list, but there is one thing that I would like to point out. In the printed brochures around that have the list of sessions, there is a typo there about the session that talks about network virtualization. So this session is actually happening in this room right now, I think, at 10:30. So if you want to learn more about network virtualization, just stay here. And others are sessions around understanding technologies around network more and how to design continuous available server better. Thank you very much.